This video is going to continue our discussion about what the graph of f prime tells us about the graph of f. Many times on the AP test, you're going to be given the graph of f prime and asked to answer some questions about the graph of f. This is a shortened version of the notes that we have previously received. If f prime is positive, that tells us f is increasing. Positive means f prime above the x-axis. Above the x-axis. F prime negative tells us that f is decreasing. F prime negative means f prime is below the x-axis. When f prime changes from positive to negative, when it goes from above to below the x-axis, when f prime changes from positive to negative, that says that f has a relative maximum point. In like manner, when f prime changes from negative to positive, at a particular x value, f has a relative minimum at that point. The other things that we can determine by when we are given the graph of f prime is if f prime is increasing, that tells me that f is concave up. If a question would ask when f is concave up, and we are given the graph of f prime, the reason we find the interval where f is concave up, and the reason, the y, is going to be because f prime is increasing. In like manner, if the question asks, hey, where is f concave down, and we're given the graph of f prime, we're simply going to look at the graph of f prime and determine when it's decreasing. This is going to be the y, f is concave down on a particular interval. The other very nice thing about given the graph of f prime is if the graph of f prime changes from increasing to decreasing, that is, if f prime has a max point, a maximum point, then f has an inflection point at that x value. Because here it says f prime changes from increasing to decreasing, that says if f prime has a max, f has an inflection point. In like manner, if f prime changes from decreasing to increasing, if f prime goes from decreasing to increasing, f has an inflection point. So let's answer some questions. The next example gives us the graph of f prime. This particular question says, consider the following graph of f prime. The first thing you do is you label that rascal f prime. The domain of f prime is all reals. F prime has zeros at -2, 0, 2, and 3. These are the zeros of f prime. F prime has a max, interesting, we're going to need that at -1.25. We don't know what that value is, nor do we need to know what that value is. And it has a max at 2. We know what that y value is on f prime. It's 0 because 2 was a 0 of f prime. F prime has a minimum at 0.75. We don't know what that y value is. We don't need to know what that y value is. And it has a minimum here at 2.5. Again, we don't need that minimum. So this is the nice information. We know that f prime is positive from 2 to 0 and from 3 to infinity. F prime is negative from -infinity to -2. And f prime is negative from 0 to 2 and from 2 to 3. At 2, f prime is equal to 0. So these are things that we're going to use to answer the questions that we have for this particular example. Question number 1, where is f concave up? We notice from our notes, from our cliff notes of the f prime short story, f is concave up. The reason is going to be when f prime is increasing. That's what we know from our cliff notes about f prime short story. So I simply need to find out when f prime is increasing. Well, f prime is increasing here, here, and here. Those are the intervals that f prime is increasing, so therefore, this is where f is concave up. Note that we're talking about f prime here. We're given f prime, and we want to answer some questions about f. So f is concave up. So to answer this question, we're going to say f is concave up on these intervals from negative infinity all the way to negative 1.25. The other interval is 0.75 to 2. And from 3 to positive infinity. Why? Because f prime is increasing. This is your y. You don't get all the points if you don't state why. And this is simply your reason, given the graph of f prime. I'm going to skip this next question and go right where the x values where f has a maximum point. If I notice on my cliff notes, f has a maximum when f prime changes from positive to negative. If you need to reread your cliff notes, please do. F has a maximum point when this happens. So let's look at the graph of f prime and find out when f prime changes from positive to negative. And I'm going to erase my yellow real quick and find out, is there a value here? We'll do it in yellow. When f prime changes from positive to negative, above to below. Well, it's going from below to above there. It's going from negative to positive there. Oh, f prime is going from positive to negative here. And that's the only place that f prime changes from positive to negative. So I say f prime change, or f has a max. F has a max at x equals 0 and y, and there's my reason, since f prime changes from positive to negative there. Let's go right to this question, the next question. Where is the graph of f increasing? Want to know where f is increasing this time. And if I look at my cliff notes, it's nice to write the reason first. If you're given the graph of f prime, then all you have to do is find out where. Then you just find the intervals where your reason happens. So if you're given f prime, f is increasing when f prime of x is positive. That is when f prime is above the x-axis. So let's find out where f prime is positive. When f prime is positive, f is going to be increasing. Let's go back up to my graph and find out where this graph is positive. And then if I notice, went to the next screen, sorry. If I notice here, where is f prime positive? Well, here. So on this interval, right here, on this interval, f prime is positive. Where else is f prime positive? Well, f prime is positive over here on this interval right here. So this is the interval. This interval and this interval is the interval where f prime is above the x-axis, positive. That's where f is increasing. So I'm going from negative 2 to 0, and I make the statement, we use blue, f is increasing on negative 2 to 0, and from 3 to positive infinity. Why? And this is your reason, since f prime is positive. Very simple. If this were an actual AP, this particular portion would be worth 2 points. 1 point for the interval, and 1 point for your reason. Your reason comes right from your cliff notes. Pretty straightforward. And I'll finish quickly with this last question here. The x value is where the graph of f has an inflection point. If I notice from my cliff notes, f has an inflection point given the graph of f prime where f prime has max points, maximum points, or where f prime has minimum points. You can say relative min if you want, or you can just say a max point. We can put in relative if you so desire. Relative max and relative min. I will abbreviate the relative. So let's find out where f prime has a max point, because this is going to be the reason why f has an inflection point given the graph of f prime. So let's go back here. Oh, and I notice, let's erase the yellow. Let's erase the green. Let's find out where f prime has a max. Right here. F prime has a max, and right there f prime has a max. So those are two spots that f has a maximum. So we're going to write that down here. F has a max. Pardon me, f has an inflection point. Inflection point. At x equals negative 1.25 and at x equals 2, since f prime has a max there. And if I go back, I'm going to look, see if f prime has any minimum points. And sure enough, f prime does have some minimum points. At this point right there, 0.75, and at this point, 2.5. So those are two more x values where f have inflection points, since f prime has minimum points at those x values. So let's go back to those x, to our question. F has inflection points, also has inflection points. At x equals 0.75 and at x equals 2.5. Why? Since f prime has minimum points there. This would be your reason. So there's 4 x values where f has inflection points. Negative 1.25, 2, 0.75, and 0.25. Why? Because f prime has relative max or relative minimums there, respectively. And this concludes this particular example of f prime short story.